Okay, today I'll be solving Cambridge International AS and A-Level Maths paper 9709, paper 1-2, major 2026, and this is the paper before the retake. So let's start. Okay, so the first question is about integration. You can see the curve, the equation of the curve is such that dy dx is equal to this. The curve passes through the point 4 minus 9. Find the equation of the curve. Okay, so we can write this as y is equal to integration of 2x minus 6x 1 upon 2 with respect to x. And next step is we will integrate this. This will become 2x. We'll add 1 to the power divided by new power minus we will add the power, so plus 1 upon the new power, which is going to be 3 upon 2, plus a constant. Then we'll write this as y is equal to, so 2 cancels with 2, that becomes x1 plus 1 is 2 squared minus, and this 3 1s are 3, and then 3 2s are 6. Okay, and then this 2 is going to come up, we'll multiply by this 2, and this will become 4. So 4x 1 upon 2 plus 1 is equal to 3 upon 2 plus c. Now we want the constant c, so we will substitute the point, which is 4 and minus 9. 4 and minus 9. So minus 9 is equal to 4, the whole thing squared, minus 4 is power 3 upon 2 plus c. So c is equal to okay, so it becomes 16 minus 9, so c is equal to 7. So our equation is equal to y is equal to x squared minus 4x 3 upon 2 plus 7. This is our equation. Okay, next question is question number 2. Okay, describe fully a sequence of two transformations which transforms the graph y is equal to fx to graph y is equal to f4 minus x. Okay, so we can see that there's a minus x, which means a reflection, and in the y-axis. Okay, we can write this down as, first of all, y is equal to fx, and okay, if you write reflection in the y-axis, reflection in the y-axis, that just does this f minus x, it does this. Okay, so because we do this because you can see that there's a minus x, then that means a reflection in the y-axis, and then followed by okay, now this is where it gets tricky, as you can see that it's minus x, and this is a translation. You might write this as 4 0, because x 4 and then y 0, and this is wrong because the bracket always lies. Okay, what I mean by that is, if you take something like this, x minus 4 is equal to 0, you don't say that x is equal to minus 4. That is wrong. Okay, because if you solve this, actually this becomes x minus 4 is equal to 0. Okay, and x is equal to 4. This is the actual thing. So in this case, okay, in this case, the I'll do this, that translation, wait a minute. Okay, translation is actually 40 here. Okay, you might get confused that I just told you not to write this. What I mean by this is, okay, this happens, right? So we write this as 4 minus an x isolated, not, we don't write it with the x, okay? And then if we do translation plus 4, okay, so remember in the bracket this will be minus 4, so in the bracket it will be minus 4, not 4, okay? So what I'm saying by this is this becomes this. Okay, if we add these, okay, this will become f minus, and then in the bracket it will be x minus 4, like this. And in the question you see it's, you know, expanded, okay, it's plus 4 and minus x. So if we expand this, what will we get? We'll get the same, like this, because minus x and then plus 4. That's why we did in the translation we did plus 4 and 0, because in the bracket it will be x minus 4, and the minus of the reflection is outside the bracket, and if we expand it, then it will become the same, okay? So that's that. Okay, and it's better if we write this translation, see, never mind. And also basically the reflection in the y-axis is considered this, okay, and the translation is like this. Wait, let me explain it to you. So the translation is kind of different. If we have x minus a plus 4 plus b, all right, so basically that is translation with the vector a b, okay? So always remember the bracket always lies, okay, it always lies, and we are the opposite in the translation. This is the, okay, this is the real one. So basically if you have a graph, and okay, think of the graph like this, okay, and if we translate, if we reflect it in the y-axis, we will get this, right? Let me write it on the same distance here, same distance here, okay, so it becomes like this, okay, and then we'll translate it plus 4 to the right. This becomes, it becomes almost like this, okay? So basically this reflection will change the sign of the translation, so don't get confused. Don't write as, don't think that there's a plus 4 in the bracket and we'll write the plus 4 in the translation, okay? Right, question 2 part B, okay, we have the curve equation. This is stretched with a scale factor 1/2 in the x direction. So stretch in the x direction, factor 1/2, we write it in a short form, and it is n is translated by 0 minus 3. Find and simplify the equation of the transformed curve. Okay, so now first we will write it as this, right? Y is equal to fx, alright, so we can say fx is equal to x cube minus 3x minus 4, okay? Alright, the first thing that we have is it is stretched in the x direction with a scale factor of half, okay? Okay, remember this, stretch in x direction is like so, f a x, okay, and when we write the scale factor, actually again the bracket will lie. How? Because the scale factor is actually, the actual scale factor will be 1 upon a. Whatever the bracket will have multiplying with x, we'll take a reciprocal, okay? So basically, in inside we'll write the reciprocal of the scale factor. So for example here, it's the scale factor is 1 upon 2, right? So in the bracket we will actually write as f2x, okay? Because the bracket always lies with the x values, okay? So the first thing is stretching the extraction. So we'll apply this thing, okay? So it becomes so f2x, okay, is equal to, now we'll replace x with 2x, okay? So this becomes 2x, 3 minus 3, 2x minus 4. So this becomes 2 cube is equal to 8, x cube minus 6x minus 4, okay? Now okay, now we see that it is translated by 0 minus 3. So in the x direction it's nothing, and in the y direction it will move down 3 times, okay? So the y never lies, okay? So for example, fx plus b, the translation will be 0 because nothing's there, and b, okay? So we'll just write the b ahead of the function, okay? So that becomes f2x, okay, and minus 3 is equal to this thing, the function, okay? And we'll just write the minus 3 at the end, okay? So that we can just simplify that, and this becomes 8x cubed minus 6x and minus 7. This is our simplified transformed curve equation. Finally simplify the equation of the transformed curve. So this is the equation, okay? Okay, the next question is question number 3. The equation of the curve is this. Okay, the equation of a line is this, okay? Find a set of values of k for which the line intersects the curve. Line intersects the curve, okay? So this is basically a quadratics question. So it said that the curve has equation y is equal to kx squared minus 5x minus 6, and the line had equation y is equal to 3x minus 7k, okay? So again, they intersect, so that means we will substitute them, okay? So this becomes y is equal to, sorry, kx squared minus 5x minus 6 is equal to 3x minus 7k. Because they're both equal to y, so we'll just equate them and simplify that. This becomes, we'll shift these to the other side. This becomes minus 5x minus 3x plus 7k minus 6 is equal to 0. Simplify this, we'll get kx squared minus 8x plus 7k and minus 6 is equal to 0. Alright, so here it said set of value, find the set of values of constant k for which the line intersects the curve, okay? It didn't specify that they intersect at 2 points or 1 point, so we're going to consider both points, okay? So that means that the, okay, first find a is equal to k, b is equal to minus 8, and c is equal to 7k minus 6, okay? So it didn't say that the line intersects at 2 points or 1 point, so we're going to consider that it's both. So minus 4ac is greater than equal to 0, okay? So minus 8 squared minus 4ac squared minus 6 greater than equal to 0, okay? Okay, 8 squared is equal to 64 minus 4k. We're just going to multiply these both. which is then going to multiply this bracket. Okay, so it's like this: squared minus 6 is greater than or equal to 0. This becomes 64. Okay, so I did a mistake. This is not 7k squared, it's 7k. So this becomes 64 minus 28k and plus 24. Okay, 24 is equal to 0. So this is k squared, sorry, again it's k. So this becomes 28k squared plus 24k and plus 64 greater than or equal to 0. So here we have to solve this quadratic equation now. Okay, let's break it down. Okay, so first of all, let's change the sign. This becomes, you can take minus common and then divide it on the other side. So this becomes 28k squared minus 24k and minus 64. And remember, if you change the signs of each one of them, this sign flips. Okay, so this becomes less than or equal to 0. Okay, and then you can simplify this, but let's see. Okay, I think we can divide by 4 each of the terms. So for this becomes 7k squared minus 6k, I believe, and 64 divided by 4 is equal to 16. Minus 16 is less than or equal to 0. Okay, so we can factorize this, and the two values will be, okay, one of them will be a minus 7 times 16 is equal to 112. 112 is divisible by 14 and 8. Okay, so the 14 will be negative, so this becomes 7k squared minus 14k and plus 8k minus 16 is less than or equal to 0. We can take 7k common, so k minus 2, plus 8, so k minus 2, okay, less than or equal to 0. All right, so we get k is equal to, write it fully, k minus 2 is equal to 0 and 7k plus 8 equal to 0. K is equal to 2, k is equal to minus 8 upon 7. I just ignored this for a little bit to find out the values of k, and now we can do this. Okay, to find out if this is like so, okay, we don't know if we should write this as this, okay, or k is less than a and k is greater than b. So for this we will make a graph, okay, an example graph like so, and this is less than 0. Y is less than 0. Okay, so below this, okay, below this will be this, this will make this. Okay, so if this is, okay, if y is less than 0, okay, we'll consider that, okay, imagine this, there's a point here, okay, and it's going like less than 0, right? Y is less than 0, so it goes down, it always goes down, so it converges to a point. So k is sandwiched between these 2 points, and this is the main reason I'm explaining this. And if for example y is greater than 0, okay, now think of it like this: when it goes out here and it goes out here, okay, so the graph will go on for infinity. Okay, it will go on like this is forever, and like this forever. We don't have a specific range. It will diverge out. Okay, so basically take this point as a, this point as b, right? So it's less than a, because of course when a graph turns out, it goes there and there. Okay, so what I mean by this is, if you look at here, so this goes on and on and on right there. So k is less than a and this is b, k is greater than b, then it will go out there. Okay, because y is going up and then it diverges out. So here in this case it's this, okay, it's this. So the answer will be k is between these two, so it's this. K is greater than the smaller value, okay, and it's less than the bigger value, so this is our answer. Okay, sorry, I forgot the equal sign. This is the important thing because it's, you know, less than equal to here. So this is our answer. Okay, now the next question, question number 4, we have the binomial expansion. Okay, the coefficient of x squared and the expansion of this is 324. So find the value of it. So we can just expand this minus this expansion and isolate the x squared terms and equate minus them and equate it to 324. Okay, first the first expansion is 2 minus qx power 4. Okay, so this will become 2 4 plus 4c1. We're just going to apply the expansion, so 2 3 and then minus qx1 plus 4c2 and 2 power decreases minus qx is to power 2. Okay, so we don't really have to, you know, expand these really. You could just find the x squared term. This is the x squared term, of course. So, and if we like expand this, and we will get, see what we will get, 4c2 times 2 squared. So we get positive because square cancels. So we get 24. Let me write with a good color. We get 24q x squared. Okay, this is our coefficient of x squared. Okay, the next term is going to be 1 plus 8 upon qx. Okay, 1 plus 8 upon qx power 6. Find the x squared term. So again, we can just ignore the 1, by the way. So 6c1, because it's going to be just 1, and 8 upon q x1. This is not an x squared term, so we ignore it as well. So 8 upon q x, the whole thing squared. This is our term, so this is 6c2 times 8 squared, so 960 upon q squared. Also, by the way, this is also q squared. Just remembered, because look, q squared. Okay, so we get this. Okay, now we can just subtract these two things. 24q squared. We can just take away the x squared, by the way. So this and minus 960 upon q squared is equal to 324, as the question told. Okay, like here, 324. So now we have to use some simple algebra here. Okay, what we can do is take the LCM here. So q squared multiplied by this becomes 24q4 upon all thing upon q squared minus 960. Now both of these denominators are q squared is equal to 324, and we can just take q squared there. So this becomes 24q squared 4 minus 960 is equal to 324q squared. So we'll bring it in this side. This becomes 24q4 minus 324q squared minus 960 is equal to 0. So this is a disguised quadratic. Okay, and now this is divisible by what? Okay, let's try 24. Is it divisible by 24? No, this is not divisible by 24. Okay, so divisible by 8 maybe. T24 divided by 8. No. Okay, first let's do it like by 2. Okay, so it's easier on us. 12q4 minus 324 divided by 2, 162 q squared minus 480 is equal to 0. Again we can do it by 2 again, so q4 minus 81 q squared minus 480 divided by 2 is 240. So yeah, this is not further possible because this is not divisible by 2 and this is divisible by 3 and 2, so wait, maybe 3. Yeah, okay, we can do it by 3. This becomes 2q4 minus 27 q squared minus 240 divided by 3 is 80. Okay, we can't simplify more. Okay, so now we have to solve this. I'll solve it above here. Okay, in which color do I do? Okay, so this, I'll just solve it here. Okay, let q4 be m squared. Okay, so this becomes 2m squared minus 27m minus 80 is equal to 0, and our factors will be, okay, 2 times 80, 160 divided by 8, now 5. Okay, 32 and 5, yeah, and 32 will be negative, I think so. Minus 32 plus 5, minus 32 2 plus, plus 5, okay, 5m minus 18 is equal to 0. I'll take 2m common, this becomes m minus 16 plus 5 common, this becomes m minus 16 as well. This becomes 2m plus 5 m minus 16. M is equal to minus 5, m is equal to 16, sorry, minus 5 upon 2, this becomes 16. And so we're not done yet. Okay, I'll just continue here because I don't have space. I can just continue here. So after expanding this, we come, okay, we did that q4 is equal to be m squared, so q squared is equal to m, so this becomes q squared is equal to minus 5 upon 2, and q squared is equal to 16. Okay, so of course we can't take an under root of a negative term, so this is cancelled. So q squared is equal to 16 and q is equal to plus minus 4. So this is our answer. Okay, it's a long question but it's easy. Okay, let's see, just take the expansions and solve them. Okay, so it's just a lengthy question, it's not that difficult. Okay, q is equal to plus minus 4. Now question number 5, we have prove the identity. Okay, this seems simple. Okay, we can try this. And okay, first take the LCM. We'll prove the left hand side. Okay, left hand side. So we can take the LCM, so this becomes 1 minus sine, okay, 1 minus sine theta, 1 minus sine theta again. We can just take a square of the bracket, but I didn't, plus cos square theta upon these two terms, which is equal to cos theta 1 minus sine theta. And usually people just expand this. I don't like to do that. Okay, because if you look in the equation, in the identity, we have like cos theta isolated, so we might have a numerator which cancels with this, so we can leave the denominator like so. Okay, so I'm just going to solve the numerator now. Numerator first. Okay, so we can just say that, okay, we can just expand this part first. So it's 1 minus sine theta minus sine theta plus sine square theta plus cos square theta upon cos theta. Okay, we're just doing the numerator, so we can ignore the denominator for now. Okay, now remember one thing, that this is an identity which is okay, now this is an identity use, and the identity is sine square theta plus cos square theta is equal to 1. Alright, so we can just say all of this is equal to 1, so this becomes 1 minus sine, so wait, just okay, this 2 becomes minus 2 sine theta, okay, plus 1, okay, upon, I can just leave that denominator for now, so this becomes 2 minus 2 sine theta. Now full equation, which is 2 minus 2 sine theta upon cos theta 1 minus sine theta. So don't get confused here, we can just take 2 common here, which becomes 1 minus sine theta upon cos theta 1 minus sine theta. So this cancels with this and we get the answer 2 upon cos theta, hence proven, because you can say up here it's 2 cos theta, okay, 2 upon cos theta. So it isn't that hard, but when you keep the denominator unsimplified, it becomes very easy, and you just have to know that this single identity here, we don't need to know the tan one, so we can just simplify this and we get this. Okay, alright, part B, hence solve the equation. Okay, all of this is equal to this for this. Okay, remember one thing, and the next part after the identity says hence, so all of this side will use whatever the opposite of this. So if it uses this, okay, we will use the other one, which is 2 upon cos theta. Okay, we will never use the one the question gives us. Okay, so in this case it's trying to say that 2 cos theta is equal to tan cube theta upon sine theta. Okay, so for this, remember, okay, so now here, okay, let's try to expand this. Okay, now identity used here is this, I have to know this, that tan theta is equal to sine theta upon cos theta. So no matter the the power, we can just add the power to all three of them. Okay, so this becomes 2 upon cos theta is equal to sine cube theta upon cos cube theta times 1 upon sine theta, because I just took the denominator to the side. Okay, it's just the same. So now we can just cancel this with this, it just becomes sine square theta. Okay, this becomes 2 upon cos theta is equal to sine square theta upon cos cube theta. Okay, so we can just take the cos theta to the other side, so this becomes 2 is equal to sine square theta upon cos cube theta times cos theta. So again, this cancels with this becomes squared, so we're left with this. Now, okay, again we can just, to make it easier on us, okay, we can just make this into, again, I don't have to write it again, because I just told you that sine upon cos, no matter the power, is equal to tan. Okay, so we just write this as tan square theta, and that will make it easier for us. We can do it other ways. How, you may ask? We can just take the cos square theta to the other side, and we can use this one, sine square theta plus cos square theta is equal to 1 identity, by changing cos square theta because cos square theta is equal to 1 minus sine square theta, right? So we can just like substitute cos square theta with this and solve with respect to sine. But to make it easier on ourselves, we can just use tan, okay? You can even use cos as well, because we can change sine square theta is equal to 1 minus cos square theta, okay? We can do it on with all three methods, okay? So I'm going to use tan square theta is equal to under root both sides, so we get tan theta is equal to, of course you can't forget the plus minus, okay? This is important, very important. So the theta will be tan inverse under root 2. Theta is equal to 54.7, one decimal place, remember always. And okay, tan is both positive and negative, so it will be in all four quadrants, okay? And the quadrants are where all positive, sine positives, tan positive and cos positive. So tan is positive in here and here, tan is negative of course in the remaining ones. So here theta is the same, here you minus 188, here you plus 180, and here you minus 360, okay? So we're going to do this all with this theta. So this becomes theta is equal to 54.7 and theta is equal to 180 minus 54.7, which is equal to 80 minus 54.7, 125.3. Theta is equal to 180 plus 54.7, which is equal to 234.7, and theta is equal to 3 minus 54.7, which gives us 16, minus 54.7 is equal to 305.3. So again the answer is theta is equal to 54.7, 125.3, 234.7 and 305.3. This is our answer, okay? So, and it's in range because it said between 0 and 360 inclusive. Alright, the question number 6. It is that 3 points PQR are this, this and this respectively, where P and R are constants. It is given that PQ is perpendicular to QR, so that P is equal to 2R minus 10. Alright, let's try to visualize this, okay? A reminder that always try to make a diagram to make it easy. So here it said PQR is this, so we can write it P is what, 0 and P, right? 0 and P. Q is 8, 6 and R is R10. Okay, 10. Okay, now it said that PQ is perpendicular to QR. Okay, we don't have to make it an exact representation, but we can do this and this and this. Okay, so now Q, so P, R, so PQ is perpendicular to QR, right? Set here, and now we want to find P. So these two are perpendicular. Now what things can we do here? All right, I think we can try to find the distances, but I think that won't work, because when we find the P and R distance, we have two constants. It might work, but I think we will use here the gradients. Now we know that perpendicular gradients are like this, right? QR is equal to minus 1. They're negative reciprocals, because okay, for example, the gradient of PQ is 2, the gradient of QR will be minus 1 upon 2, because they're perpendicular. Okay, so we'll use that to our advantage. First find gradient of PQ. Okay, so gradient of PQ is gradient of PQ to y2 minus y1 upon x2 minus x1, which gives us minus p minus 6 upon minus 8. We are left with this as y2 minus y1 upon x2 minus x1. Okay, this is our gradient of PQ. So QR, we can find QR. Gradient of QR is equal to y2. It's okay. y2 minus y1 on x2 minus x1. Okay, so this becomes 4 upon r minus 8. Okay, so we can use this formula. This is just the actual formula that we actually use. So here we can just sub into the formula. P upon minus 8 times 4 upon r minus 8 is equal to minus 1. Now this is a negative term overall, so I'm going to make it go there. So this will become a negative reciprocal of this. So this becomes r minus 8 is equal to 8, because the negative cancels with this, and this is flipped on the other side. This becomes this. So we can just cross multiply this. Okay, so cross multiplying this will become 4p minus 24 is equal to 8r minus 64. So it's set to find p is equal to r minus 10 or something. So we will make p the subject. So 4p is equal to minus 24 goes there, it becomes positive 24. So this will become plus minus and then minus. So 8r minus 40. And then 4p, wait, sorry, we'll just take the 4 to the other side. This becomes 8 upon 4r minus 40 upon 4. I just place it on both of the terms. So this becomes 4 1s are 4 and then 4 2s are 8. 4 1s are 4, 4 10s are 40. This becomes 2r minus 10. I think we proved it. Let's see the question. Yeah, so 2r minus 10, we got that. 2r minus 10. Okay, so the next question is, next part, it is that it is further given that the length of PR is under 85. Under 85, length of PR. Okay, find the possible values of P and R. Okay, this is for 5 marks. It's further given, so it's adding on the information. So okay, let's write down what we know. Okay, P is now 2r minus 10. Okay, remember the questions always align with themselves. Like the previous part is always mixed with the next part. Okay, so remember we'll use P 2r minus 10 as 2r minus 10. Okay, so we can just copy these down. So P is 0, 2r minus 10. Right, P is 0 and 2r minus 10. And Q is I think 86 and R is 10r. Let me confirm that. Yeah, R10, sorry. Okay, we'll change that R10. And okay, PQ and Q are perpendicular. Okay. Okay, so R and 10, alright, and PQ are perpendicular to QR. So P, Q, R. So it said that this length of the PR is under root 85. So this is equal to under root 85, right? Now, if all of this is equal to under 85, we can just use the formula to find R, because they want P and R. So I substitute the y coordinate of the P with 2r minus n. So we can use the distance formula. So distance of P and R is equal to under root. Now x2 minus x1 r minus 0 the whole thing squared plus y2 minus y1 10 minus 2r minus 10 the whole thing squared, all of this in under root. Okay, so this is under root 85 equal to under root this becomes r squared, and then the minus comes here, and then this becomes minus 2r, right? This becomes minus 2r plus 20. Okay, this becomes minus 2r plus 20, because this minus becomes positive here and this minus becomes minus. So take the square of this, it becomes plus 4r squared plus 400, I believe it squared 400, and minus 2 times 20, and then minus 80r. Now the both sides have under root, so we can just cancel them. All right, this becomes r squared plus, okay, r squared plus 4r squared minus 80r plus 400 minus 85, bring 85 on this side, is equal to 0. Now simplify this, we get 5r squared minus 80r and 400 minus 85, so 315 equal to 0. Divide all of this by 5, this becomes r squared minus 16r, and 355 is equal to plus 63 is equal to 0. So the factors here will be minus 9 and minus 7, minus 9 and minus 7. R plus 63 is equal to 0. R common, r minus 9 minus 7 common, r minus 9 is equal to 0. So r minus 9, r minus 7 is equal to 0. R is equal to 9, r is equal to 7. So we can just substitute, because the previous part said what? It said the p is equal to 2r minus 10. So we can just substitute differently. This becomes p is equal to 2r minus 10, and p is equal to 2r minus 10. So this becomes 9 2s are 18, 18 minus 10 is equal to 8, and 2 7s are 14, 14 minus 10 is equal to 4, so 8 and 4. So therefore we can write this as such: when r is equal to 9, p is equal to 8, and when r is equal to 7, p is equal to 4. Alright, so this is our answer. Let's see if there was any restrictions, like, see, I said it is given that the further length, that pr is equal to this, possible values of p and r, no, there is no restrictions. So okay, this is the answer. Then question number 7. All right, the curve has equation y is equal to 3x minus okay, it's not very clear in the question, but I'll write it again. It is 3x minus 1 upon 2 minus 2x minus 3 upon 2, right? Okay, so the curve has a question this. So the curve has a single stationary point. So curve has a single stationary point like this, singular point, stationary point, and where x is equal to k. So it said that x is equal to k here, and k is positive. K is positive, okay. And the final value of k. Okay, stationary point, you should know, is dy upon dx is equal to 0. Is when we find the stationary point, right? So what we can do is okay, we'll find dy upon dx with x as k. We get, alright, for this derivation, okay, for when you drive something, okay, you bring the power down. So bring the power down, multiply by this, so this becomes minus 3 upon 2 x, and decrease the power by 1. So minus half minus 1 is minus 3 upon 2, okay, minus 3 upon 2. And the next term, again we drop down and this becomes plus 3 because the sign cancels and 2 cancels, so we're left with 3x. So minus 3 upon 2 and minus 1 is minus 5 by 2. Minus 5 by 2. And now we'll equate all of this is equal to by 0 and substitute x. So this becomes minus 3 upon 2 k minus 3 upon 2 plus 3 k minus 5 upon 2 is equal to 0. Okay, because stationary point happens when dy dx is equal to 0, and at that point x is equal to k, so we want to find k, so we substitute it. Okay, and this is negative. All right, now okay, minus 3.2 okay, so now let's try to solve this. This will be difficult, but let's break it down. Okay, after breaking it down, okay, so k is in the numerator with negative power, so when it comes down it will become positive. So right, so we can just bring the k down, so the power will become positive. So 2 k 3 upon 2 plus 3 upon k 5 upon 2. Okay, now for this, if we let the power remain as this will become confusing. So now if you see that what is, okay, let me do this on the side. Now let's try to understand this. Okay, 3 upon 2 is equal to 1.5, right? So this basically means 1 and 1 upon 2. So k 3 upon 2 is basically the same as k times under root k. They're basically the same, okay? And so now we take 5 upon 2. 5 upon 2 is 2.5, okay? So that's just 2 and half. So yeah, so we can just basically say that k 5 upon 2 is equal to k squared and under root k. It's the same thing, okay? So if we do that, it will become easier. So then we can take LCM and stuff. So 2 upon k times 2k. Alright, don't let the k multiply by 2. The whole bracket will multiply by 2 because it's multiplying by all of this. So k under root k plus 3 upon this, so k squared and under root k, okay, is equal to 0. So the changes in denominator are that this denominator has a 2 and this denominator has one more k than this, so we can multiply all of this by k. All right, all of this times k and all of this times 2. Okay, so what that does is this becomes minus 3k upon 2k squared times 1 upon under root k, sorry, plus 6 times 2k squared dot under root k, okay, is equal to 0. So now if you see the denominators are exactly same, so we can just take it to the other side, multiply by 0, so it becomes 0. Okay, so this becomes minus 3k plus 6 is equal to 0, minus 3k is equal to minus 6, k is equal to minus 6 upon minus 3. If this becomes cancels this 2 1, sorry, then we have k is equal to 2. So our answer is k is equal to 2. Okay, right, the second part says that find second order derivative and hence determine whether the stationary point is maximum or minimum. So okay, So now we know that k is equal to 2. We'll have to use that. So dy dx is what? We had that dy dx is equal to this, all of this, okay? So we can say that we want to find d2y upon dx2. So we know that x is equal to 2, but okay, so we can say that minus 3 upon 2, and we cannot take k, we'll take x, so we'll take this, okay? We'll take this. So minus 3 upon 2x. Upon 2x minus 3 upon 2, okay, and the whole thing was plus 3x minus 5 upon 2, okay, plus 3x minus 5 upon 2, okay, plus 3x minus 5 upon 2, okay. So we want to find the double derivative, so let's find it. This becomes, okay, again power drops, multiplied by this, so negative signs cancel. So 3 upon 2 times 3 upon 2 will be 9 upon 4, okay? So 9 upon 4 x. Now again, power decreases by 1, so minus 5 upon 2 plus, minus 5 upon 2 times 3, which becomes negative 15 upon 2. To x. Now minus 5 upon 2 minus 1 is, and the power becomes minus 7 upon 2. Now this feels weird because this is a big power right here, or a very small power instead. Okay, so to find minimum and maximum, we'll see if d2y upon dx2, when we plug in the x value, if d2y is greater than 0, it's a minimum graph. If it's less than 0, if it's negative, it's a maximum graph, okay? So let's see. We'll substitute the x value, which is 9 upon 4, 2 minus 5 upon 2 minus 15 upon 2, 2 minus 7 upon 2, and this gives us 2, and okay, this is a decimal value, but okay, this gives us negative 0.265 and more stuff. So of course it's a negative, then this means that d2y upon dx2 is less than 0, so it's a maximum graph, okay? We find d2y upon dx, okay. Now part C, find the find the area enclosed by the curve, the x-axis, the line x is equal to k, the line x is equal to 4. Give your answer in the form, of course. Okay, these ones are kind of tricky because you have to find them in third form, okay, and find the area enclosed by the curve and all of that stuff. Okay, so let's try to make a representation like a graph. Okay. Okay, so we can make a rough idea what it means. Okay. First of all, we know that k is equal to 2, and it said that k is equal x is equal to 2 and x is equal to 4. So we can perhaps use these as limits because it wants the area. So of course it's integration. So for example, this is the curve, okay, something like that, and this is x is equal to 2 and x is equal to 4, and inside between the curve, the x-axis, this, and 2 and 4. Alright, so we can just integrate this. Okay, now we need to know the curves equation, of course. So let's see what it is. Okay, x minus 1.22. Okay. All right, so we can just add it. We know that y is equal to 3x minus 1.2 minus 2x minus 3 upon 2. I hope this is it. All right, so a is equal to integration 4 to 3x minus 1 upon 2 is 2x. What is that? All right, what, how? Okay, let me just erase this. Okay, let me just erase this thing. Okay, okay, yeah, sure. So now 1 upon 2 and minus 2x minus 3 upon 2 with respect to x, of course. Okay, now let's integrate this. Okay, let me use another color. Okay, all right, so a is equal to integration of 4 to, okay, it's better if I do this. Okay, 4 2, because I'm going to integrate it. Right, 3x power increased by 1, so that's 1 upon 2 upon new power. Okay, 1 upon 2, and again 2x increased by 1, so that's minus 1 upon 2, and all of this upon minus 1 upon 2. Okay, and wait, this is x. Okay, so we can just simplify this and add the limits. So 4 2. Okay, this 2 will come up here, right? This will become 4 2 6x 1 upon 2, and this thing will become, I believe, positive 1. Oh no, actually no, yeah. Okay, so this becomes positive 4, sorry, positive 4 x minus 1 upon 2. All right, so now we can subtract the upper limit by the lower limit. So 6 4 1 upon 2 plus 4 4 minus 1 upon 2 minus now 2 upon 2 plus 4 2. So, okay, so if I just do this in the calculator, this will give me a decimal. Okay, because yeah, so I have to do it step by step. Okay, upon 2. First I'll solve the left bracket. Alright, the left bracket gave me 14. Okay, so a is equal to 14 minus, now this thing, now this will give me, yeah, this gives me a decimal. So let me do it normally. So this, I can write this thing, all this like so, 6 under root 2 plus 4 upon under root 2. Okay, because this is a negative, so this will go down under root 2. Now, okay, which form does it want it in? Okay, it wants it in a plus b under root c. Okay, now you don't need to specifically know surds here, but you just need to know one thing though. Okay, and that is that we have to rationalize this. Okay, so how rationalizing works, that you multiply by the fraction with a denominator like this. Take the denominator and multiply both things by it. Okay, so let me do it on the side. This thing becomes okay, these two are multiplying, so this becomes under root 2 whole square. This becomes like this, right? 4 under root 2 upon under root 2 the whole thing square, so square cancels with under root, so this becomes 4 under root 2 upon 2. Okay, so remember that. Now if I try to write it like so, okay, so this then becomes, we can write this as a 14 minus 6 under root 2 plus, okay, yeah, sorry, so we can just do this. This becomes 2 under root 2 plus 2 under root 2. This becomes a is equal to 14. So it's like this plus 2. Yeah, okay, so this becomes minus 8 under root 2. Okay, this is our answer. A is equal to 14, B is equal to negative 8, C is equal to 2. Okay, this is the answer. Okay, so this is the end of the part 1. Okay, so I will be uploading a part 2 for this paper. Okay.